Good morning, everyone. This is our lesson for lesson 6 of Patterns in Data Management, chapters or grade 7. I'm going to be working through this book, and you can follow along with me. I'm going to do a couple of these questions, and so you can check your own work. All right. So, what are some of the important concepts of bar graphs and graphs in general? They usually have 3 different elements. So the first one would be that bar graphs they can be either made vertically or horizontal. And they typically have axes. Axes are this distance right here. This is an axis, and this is an axis across. Usually it has information, which is the data that's being given by the bars. It also has scales, which is the degree of separation in between each part of one of the axes, typically. And then you also have labels, which tell you what the purpose of the graph is for and where you're getting this information from. So here we have a horizontal bar graph, So we have a horizontal and a vertical bar graph, and they're asking us to complete the other one. So right now, so draw a horizontal bar graph in figure 2 to show the same data as the vertical bar graph. So vertical is indicating the way that the data is being presented. Okay, so I'm going to do the exact same as this, except I'm going to do it in a horizontal method. So what I can say is, okay, well, E had the value of 1. So I'm going to have, E is going to have 1. So I'm going to do a little line like this and say, okay, that is E. D had 2. Like this. C had 3. It's awkward to draw sideways like this. B had 7. So all the way up here. I'm going to draw the line. And then A had 4. All right. Sorry, the bridge makes it hard to read too. All right, so if we look at these 2 different bar graphs, which one is going to, which one gives a better indication of what the results are? Okay, so which one tells the information quicker? Well, it depends on what the question is. So your question could be, so what scale was used in the bar graphs first? The scale was a scale of 2. There's 2 in between every single one. 0, 2, 4, 6, 8. Do you think it was a good choice? Why or why not? Oh, sorry. That's what I was asking. I think the scale, it probably could have been better. It could have just been 1. But it's not horrible to read. Now, what information, which one tells you more, right? So if you're asking the question, okay, what's the most common mark that students got on the test? You could see it. You could say this one probably tells you that information easier, where this one probably tells you the number of people that got each test answers. So like this is easier to read than this in my mind, just to find out, okay, like how many people got B? Well, it's clearly 7, right? Where you could see this one says, okay, well, which one had the most? Well, that's B. So it depends on what the purpose of your graph is. That would tell you which one's more important or more useful. Okay, so let's look at number 2. And we're going to do, let's just do A and B. So draw a bar graph for each frequency table. Use the grids at the bottom of the page. For each table, or for each graph, you will first need to decide the scale. Example, in part B, you must use the scale 5, 10, 15, 20, 25. In this scale, 5 students are represented by each division. So, let's see. So this first one, yeah, it's done for us. So it's going to give us a scale of 2, and we're going to go all up to 9. So now I would want to write this information in a place that's nice and neat. I don't exactly know where they'd want us to write it, to be honest. You could write it over here, or you could write it over here. I don't really like it here, but I don't think there's a lot of room. So let's say we're doing a scale of 2. And then so we start at 0, do 2, 4, 6, 8, 10, 12. Okay, and we're going to put this information. So A should be the value of 2. B should be the value of 9. 9. Okay, then we have 6 next. D we have 1. And E we have 0. Okay, now this next one is done 5, 10, 15, 20. So 5, 10, 15, 20, 25, 30. And A has a value of 16, so slightly above. B has a value of 23. What I don't like about what they're doing right now is they didn't give us a lot of room to work on it. So I'm feeling that my hands it's hard for me to do this super, super neat, which is kind of one of the things that you want to do while you're doing this type of work. You want to do it neatly, so it's very visual and obvious. And then E is a 2. Right? So that's kind of how I would do it. And yeah, we should be able to indicate what's the scale on the left side, and then we have our actual marks over here. Okay, let's look up on this question over here. Okay, so we're looking at number 4 now. A company asked 100 females, 100 males whether they agree or disagree with the statement. This was the data they collected. 62 males and 54 females agree. Look at the 2 graphs. Do both graphs show the same data? Well, let's make sure of that. So the males are approximately around 62. Females are approximately around 50. Okay, so yes, they do. Which graph makes it look as though that more than half of both females and males agree? Okay, so graph A, let's call this one graph A, and this graph B. Graph A shows that a lot of people are in favor of it, like pretty visually. Okay, which graph makes it look as though very few females agree? Well, that's graph B. Which graph suggests a great difference in opinion between males and females? That's also graph B. Which graph better represents the data? I would say graph A, and because it's more, it gives a sense of scale versus a small part. Okay, so it gives us a scale of 100 and says, well, it's over 100 or it's over halfway, where this one doesn't give us that sense of scale. It also doesn't turn 0. All right. This one, describe the scale on each bar graph. This one starts at 0, count by 10,000, stop at 50,000. All right, this one is start at 47,000, count by 100, stop at 47,300. Which graph makes it easier to tell the difference in votes for each candidate? So this one's graph B is going to be more obvious. Who won the election? It's going to be Miss C. Okay, and then I did this next one in my book, number 5. Oh, I'm sorry. Oh, I did all that without you seeing it. That happens sometimes. This is how I filled it in. Okay, and then I did number 5 in my book, and the question was asking us to. The question was saying a company had $2,000 in sales in March and $2,100 or $2,100 in sales in April. Draw one graph that makes it look like there's a very large difference in sale, and draw another one that has very little difference in sales. Which do you think is more accurate? So I drew 2 graphs, and I determined that my scale would be 0 to 2,500, and this one would be 0 up to 2,100 as well. Okay, now the scale itself is different because I'm going up by 25 in between every box, where this one went up by 500. So which one's going to have the better value? This should have this title should be over here too. Which one shows the information more clearly? Well, this one makes it seem like there's a massive range in between these two numbers. This one seems like it's fairly clear and obvious. Now, which one do you think is more accurate? Or sorry, which one do you think is a more accurate graph? Well, I think that realistically, like, the difference of 100 is not so significant that it needs to be portrayed in this way. So my thoughts are, in one sense, this seems like it's not a big problem. If you're a small company, this $100 could be a big difference. I think this is probably the more accurate one. This one doesn't tell the whole picture, unfortunately, because it doesn't give a sense of scale, like how much money is actually. So $100 over $2,000 is 1/20th of it, which isn't massive amount, right? This one's a little bit more obvious, saying, okay, like we're doing well, and this we did a little bit better. This one seems like we're not doing very well, and all of a sudden we're doing amazing, but it's only $100 difference, which isn't really a lot of money. So I'd say that probably graph A. This is graph A. This is graph B. I'd say graph A would probably be doing a better job of portraying the information. All right, so that was page 58 and 59. I hope that was helpful, and yeah, please come to the math block tomorrow or this morning.